Okay, 1.6e. I am sorry this has taken so long. This is one of the longest sections that I've seen in a long time. All right, example 23, page 74. We've got x minus 3 squared minus 25. So here we go. Here's my first term. Here's the second term. 2 parentheses. Okay, square root of 25, get those. This is the part that looks tricky but really isn't. Because all you're doing is taking whatever is squared, and putting it here without the squared sign. Okay, that's all you're doing there. Now what we have to do is combine like terms. So we have a negative 3 plus 5. And a negative 3 minus 5. And now you're done. And that's it. Okay, on this one they're trying to throw you. One of the things you want to notice here is we have 4 terms. 3 of these terms right here is a perfect square trinomial, meaning x, 5 times x is 5x times 2. Does that give me 10? Yes, it does. So it's a perfect square trinomial. So I'm going to put this in parentheses and just let this drag along with me as I go through here. So, perfect square trinomial, parenthesis, squared. This sign down here. Square root of this, square root of this, and life looks good there. Minus y squared. So what that looks like, and what we're going to do here, is continue to factor this just a little bit more by changing this to x minus 5 minus y times x minus 5 plus y, because this is the difference of 2 squares like we have been doing in this section. Can I take the square root of x minus 5 squared? Yes, it's x minus 5. Can I take the square root of y squared? Yes, and it's y. I've got a minus sign, which I have to, so I have a minus here and a plus here. And now I have an answer like what I've got. So it's very, very similar, actually, to something like x squared minus 25. I can take the square root of that. I can take the square root of that. I get x minus 5, x plus 5. Square root of both of those with opposite signs in between. That's what I did over here. I've got one term here that's squared. I've got a term here that's squared. So I took the square root of that here, in here, square root of that here, in here, put a plus sign and a minus sign, and I'm good to go. So that one is a bit tricky. Not sure how many homework problems they'll have on that, but at least you've seen one done and you'll probably be fine. Last one we're going to do. X cubed. Help if I get my pencil working. Now these are just like puzzles. These hard puzzles that you try to do to try to figure out. So let me see if I can help you. We have an x here, an x here, and an x here. So we have something common there. So I'm going to put a parenthesis around that. And I am going to factor out an x. Now I'm going to look at this. Can I take the square root of x squared? Can I take the square root of 9? If I multiply them together and then multiply that by 2, do I get 6x? Yes, that is not what I've got there. So it is not a perfect square trinomial. So doggone it, that isn't going to work for me. So this is one of those whole trial and error things that you end up doing, trying to figure out the best way to make this work. So let me get a little eraser here. Okay, so I've got this and this and this and this. One of the things that I notice here is I have 4 terms. When I have 4 terms, one of the things I want to look at is the possibility of grouping. Can I factor something out of there? Yeah, I can factor an x squared out, and I'm left with x plus 2. What can I factor out of here? I can factor out a 9, and what am I left with? X minus 2. Okay, those are an x plus 2, and I'm sorry, this is an x plus 2 as well. Let me explain why. 9 times 2 is 18. I need a negative 18. These two have to be the same. If this is a negative 18, then this 9 has to be negative. If I would have made this 2 a negative, negative 9 times negative 2 would have been a positive 18. This is one of the pieces that can really get screwy if you're not really paying attention. And like I say, I almost made that mistake. But I recognize, oh, this is a minus and this is a plus. Ooh, that can't be right. They have to be the same. And then I noticed the negative here, and that was the problem. So negative 9 times 2 is negative 18. So let's go ahead and put these together. X squared minus 9 times x plus 2. Ooh, there's something right there that looks familiar. An x squared minus 9. The difference of 2 squares. The difference of 2 squares says that I make 2 parentheses, make 1 plus, 1 minus, square root of the first term, square root of the second term, and then I've got the x plus 2 here that follows. So that is the perfect answer when you're all done there. Okay, finally, the sum and difference of 2 cubes. So the sum and difference of 2 cubes looks a bit like this. The sum of 2 cubes, the difference of 2 cubes. Meaning, what can I multiply by itself 3 times to get x cubed? X. What can I multiply 3 times by itself to get 27? 3. 3 times 3 is 9, times 3 is 27. Okay, so if I have, instead of an x cubed there, let's say that I just call it a cubed. And instead of 27, I say I have a b cubed. So that's just basically any 2 numbers or variables. That is going to equal the first term plus the second term times the first term squared minus the first times the second plus the second. Okay? So let's look at this following this formula and see where the answer comes from. So we cube the first term, we cube the second term, so what's that going to look like? It's going to be the first term is an x, no variable, no exponents there, just the variable, plus b. What is b? b is 3, okay? What number times itself 3 times is going to give us 27. So one of the things I like to do is I like to rewrite this as x cubed plus 3 cubed. So I'd like to get the cube on the first term and a cube on the second term, because then when I'm looking at writing it in this format, all I have to do is look at the numbers here. So the a, which is the x, and the b, which is the 3. We don't even care about the exponents here. Times a, which is this x number squared, minus a x times b, 3, plus b squared. B times b, well, I'll just write it this way. Okay, let's clean it up a bit. And we get something that looks just like that. So the next one, oh, I made my eraser too little. Okay, so we've got that one. Let's see if we can move that out of there. So we have x cubed minus 27. So instead of a plus, we have a minus here. So that gives me, and again, I'm going to write this as x cubed minus 3 cubed. And that equals a minus b times a squared plus ab plus b squared. Sorry about that. Okay. The only difference between the formula for a minus, a difference, and a plus is this part right here and this part right here. They're just different signs. In the other one, this was a plus and this was a minus. And in this one's a minus and this one's a plus. Okay, so let's use this one and solve it. So the difference in my first terms, and it's the last term, times my first term squared plus my first term times my second term, not cubed, just the 3, plus the 3 squared. And again, clean it up a bit, moving things around so that they make more sense. Instead of x3, 3x. Oops. And we're done. So when I have something like 64 plus x, plus x squared, okay, or I'm sorry, cubed, we're in cubed now, is, I'm going to rewrite this as 4 cubed, 4 times 4 is 16, 16 times 4 is 64, plus x cubed. Okay, then I can ignore all of this and just look at that. And according to my formula, I'm going to have one parenthesis that says the first term plus the second term times, and then there's 3 in here. If you look in the middle of 75 if you need help. First term squared, 4 times 4 is 16, minus the first term times the second term, 4x, plus the second term squared, and you get that. And you're done. All right, let's keep going. Whew. It's to be a long night. Okay, so if you remember, we're going to make this 3x cubed. So this is cubed. I'm just going to take and that's an x, the cubed root of that. What number times itself 3 times gives me 27? 3. So this right here equals this. I'm going to do the same thing over here. I've got a plus. Cubed root of 125 is 5. 5 times 5 is 25 times 5 is 125. This is already cubed, so I'll do that. So then I'm going to look at my formula. In my formula, when we're talking about the sum of 2 cubes, I'm going to take my first term, add my second term, and this will have 3 in it. First term squared, 3x times 3x. I'm going to put a minus, and I'm going to combine these two, 15xy, and then I'm going to plus the last term squared. And get 25y squared. And that's it. All right, so let's do 2 more and call it good. X cubed minus 1 over 8. So this can be written as x cubed minus 1 over 8. How can we write this with a cube up there if we put a 1/2 there? What I do is I look at the bottom number and I say, what times what times what? It's going to give me 8, 2. 2 times 2 is 4, times 2 is 8. So I'm trying to find the root or the number multiplied by itself 3 times that is going to give me this 8, and it's the 2. So there I go. So then I've got the x cubed minus 1/2. So this again is the a and this is the b. So I've got a minus sign there, so I'm going to use the formula first term minus the second term times first term squared plus first term times the second term plus the second term squared. And it gives me an answer like that. Okay, let's finish up here with this last one. Okay, several ways of doing this, and I'm going to keep with the sum and difference of 2 cubes to do it. So we're going to rewrite this as x hold on here for a minute. All right, so notice this is the sum or the difference of 2 cubes. That means the 3 has to be out here. I had been doing the squares out here, the 2 out here, but that's when we were finding the sum and difference or the difference between 2 squares. Now we're doing difference between 2 cubes. So that means I'm going to have a 3 out there. So if I look back at my formula, middle of page 75, the minus ones, it has, get a pen here, the a minus b times the a squared plus the a times the b plus the b squared. Okay. Which gives us this here, which ends up being a real mess because there's the difference of 2 squares. Okay, and then this can actually be written as squared. So when you do that, you've got a really, really huge headache. So that's it for 1.6, and I promise this last one will not be on a test. But anyway, that's what we're doing.